Hi everyone, I'm Marshall Brin from the GPO, and I'd like to start a conversation on the subject of making the experimenter platform more uniform, and I'll describe what I mean by that. So, starting at first principles without diving into the lack of uniformity, GENI provides experimenters with custom data planes, layer 2 data planes, programmable, traffic segregation. Currently you can do that with mesoscale. By GEC15 our intention is to have stitched, federated InstaGenie and ExoGenie racks from which you can build topologies. And in general, things should just work. And in most instances, depending on what you're trying to do, that's the case. Experimenters should be able to allocate resources from the aggregates using the AM API. They'll be stitched together based on the configuration in your RSpec. And then you've got your topology. You've got a bunch of networked Unix-like environments, and we'll talk more about that in a second. You've got layer 2 data plane connected with the requested topology. You've got a layer 3 control plane, which allows you to sort of get into the various resources with SSH access. You can install your software on the resources, and off you go. And that's mostly true, but it's not completely true. And that's really the subject of what we want to talk about today. There are subtle differences among Linux and FreeBSD distributions. There are subtle differences about the way that the control frameworks work in terms of your interoperations with them. And there are subtle differences in the compute node environments that are set up by the control frameworks. And these differences may matter and they may not matter. Some of them are subtle and not important. Some of them may matter, either at resource allocation time when you're trying to build your topology, or at the time when you're setting up the experiment, or when you're trying to run the experiment. So I'm going to go through some slides where I talk about areas where there are some of these differences, and I'm hoping that we can have a conversation here and then start a broader conversation in the GENI community about what are the important differences and what can we do to sort of make the significant differences less significant, or to narrow that gap. So here are some possible things that might be significant to experimenters. I don't actually know whether these are big problems or not. I did have a conversation with the XIA guys at lunch yesterday, and they were talking about the differences that they had built a number of scripts on Ubuntu, and they had scripts that were doing ifconfig, piped into grep, piped into cut, and everything kind of worked. And then all of a sudden they got a different platform that was Fedora, and nothing worked. And it was the small little subtle differences between these different platforms that if you're really counting on something being in columns 3 through 17 to pull out the IP address, well, that might not work. So let's just start with a couple of categories. Standard locations of information. When you've got your compute nodes, are there standard locations, such as things that I'd like to know, like what slice am I in from within the slice itself, from within the sliver when I'm running it? Is there a place that I can get the sliver URN? Or information like where is the request and manifest RSpecs that went into the transaction that made this sliver that I'm operating in? Are they in standard locations, or could they be pointed to by standard environment variables? Currently, those things aren't standard. If that's important, it's something that we can push on. Privileged operations. InstaGenie allows for sudo from non-super users, but certain recent Linux distributions don't allow that scripted sudo, which is, say, you have to type in the password, so it makes it hard to automate those things. That's a topic. ExoGenie sets the user up as root. So that's another difference, that typically here you are root, here you have to use sudo. That's okay, but depending on how you write your scripts, you need to be cognizant of these things. And in general, we're trying to make the environment such that you don't need to be cognizant of too many of these things. There are subtle, sometimes significant dialect differences between the RSpecs that you need to compose to talk to ProtoGenie and InstaGenie on one hand, and ExoGenie, Orca on the other hand, particularly with respect to descriptions of resources and what you want. And to the extent that we can come up with a platform, a control platform, independent way of asking for resources so that I can get what I want. If I don't really have very specific requirements of what I want. I want to be able to sort of ask for a general VM, something that's sort of in this general ballpark. I should be able to ask for that in a uniform way to all the different frameworks. Software installations. There are differences between between Fedora and Ubuntu, between Linux and FreeBSD. Are those differences significant? Are they the kinds of things that you, the experimenter, ought to know out of band? Which is, say, you go and you sort of know the difference. You go on the web and you find out these differences. Or are there certain critical things, like, say, on this machine you use apt, and on this one you use yum. I'm just making this up. Should that be part of the manifest so that you know, so that you can write scripts that say, based on what I got back, I don't need to have a big switch statement that says, if Fedora do this, if Ubuntu do this, I can do that based on attributes that are presented to me in the manifest. I'm just brainstorming here. So there are these differences. And there's a couple of different strategies I'd like to at least kick around. One is we need to be careful. The experimenters particularly, need to be careful not to depend on implementation internal details, things that seem to work, happen to work, but they're not documented parts of the API or documented parts of what the control framework set up for you. So that if there are internal representations that seem to kind of work, they could change without warning. There's nothing, those are implementation details. So be careful to sort of notice when you may be doing that, because those things may change even if the platform changes, even if you're still going to the same control framework. We're imagining that we, the GPO, or the developer community in general, could start to write some scripts or functions that isolate some of these switch statements that people are going to have to currently put into their experiment script, so that you can say, if I want to know my IP address, if I want to know the name of my host, if I want to know my slice URN, a number of things like that, you can call a uniform function, and it will, inside of it, do all the switching and say, well, if I came from Exogene, I do it this way. If it's on Instagene, this way. If it's on Fedora, I do it this way. We'd like to, if there are a handful of things that would make a big difference, we could certainly make sure that these things are available and try to get them installed on the platforms that are available. And that leads to this one. If we can assert some standard tools and sort of say, okay, when a control platform sets up a compute node, it is recommended, desirable, to install this standard set of tools, so that anybody who wants to write a script can assume the existence of this set of tools in their scripting. These kinds of things that eliminate some of these discriminants. You may not want this. In Exogene, for example, you've got a series, you can build custom images. You may or may not want to support such services. That's your business. But I think that it may be the case that we want to set up such services to be sort of standard to allow for uniform scripting. The reason I think this is an important thing is not only to help experimenters not have to write these complicated switch statements, but if you really are dependent on a particular kind of platform, it limits the amount of, it raises the risk that you won't be able to get what you want as the experimenter community grows, and you're dependent on just these four machines that happen to sit in a certain place. Well, either they're free or they're not. But if you avoid those kinds of dependencies, then it opens up the whole set of Genie resources for you, and your chances of being able to build the topology that you want whenever you want are much greater. Finally, we could, and I've ordered these in order of cost and in terms of effort on the part of the developer community. We could augment the Aggregate Manager API and sort of make some specifications that say, when you create an aggregate, it has to be set up with certain kinds of environment variables, certain kinds of places, certain kinds of things. It's not clear that we need that sort of thing, but such a thing, if these kinds of things are insufficient, we could go down this path. But that takes a while and it's expensive. So the real question, as we identified these differences, they can be handled in different ways depending on costs and benefits. How important is it to experimenters? How costly is it for developers? Yeah, Rob.
Do you mind if I interrupt him?
No, please.
Okay, so I would like to suggest that on point 3 there, that the way what I would really like to see is some standard images that are maintained by the community that wants to use them, right? So if the aggregate managers provide, I mean, so like, you know, for example, one of the common requests that we get is people say, oh, well, why isn't Java already installed on here, right? And the answer is because there are so many versions of Java, I don't know which one you want, right? And even if I made an image that had some standard version of Java in it, as time went on, I would have to either put a lot of effort into maintaining and updating that, or you would get increasingly unhappy with how old it was. And so what I would rather see is that you know, people who are doing experiments using particular kinds of tools, people who want to use Hadoop or Cassandra or Memcached or whatever, maintain their own sets of images that they share with each other, right? Rather than saying the the aggregates are responsible for installing images that have some standards that are.
I think there's, I like what you're saying, and I think we could, we should support that, but I think there's also a path we can go down, which is to try to do more installation scripts at the beginning of setting up the VM, so that if we can build apt yum kinds of scripts that say, here are the things I need. First thing I do is I install these things, and then we carry fairly vanilla, a set of fairly vanilla images, and then we can install the Java, the Python, whatever it is that you may want on top of those things. It's a trade-off of time when you're setting things up, time to establish those scripts, and managing a number of images. I think there's a number of ways we can go here. Yeah, Nikki.
I think it's also very important though for the aggregate managers to support the same images. The way that I think the reason why many experimenters get into this problem is because they have, oh, I'm using this node and it don't has Ubuntu. So I set up my stuff in Ubuntu, and then we tell them, oh, by the way, use this node, but it don't has Fedora.
Yeah.
So now and write the stuff. So I think it will go a long way if, the experimenter says, I have 5 images and I know that all the nodes in Genie will have them. So I can write my script once and I can always ask for Ubuntu or Fedora or CentOS or whatever that is.
Agreed, absolutely. That's important.
The problem with that is that then you end up supporting all the different flavors, right? I mean,
I agree that it might be a limited set, but
Yeah.
at least.
I think if Genie were to pick 5 and say, this is what we do.
I mean, for bare metal, this is problematic, right? For bare metal, this is much more problematic than for containers. I mean, Rob, tell me if I'm wrong, but like it seems that your sort of URL-based container imaging now makes this potentially a lot easier to move these containers around to places that didn't previously have the right base that you were looking for.
Yeah, that's right.
Which many people may not be aware of. So
Yeah. Well, that we weren't aware of because we just did it.
Right. Yeah.
Right. But yeah, I totally agree. For VMs, this is much easier.
Sure.
And across the control framework, so we have done OpenVZ containers for a while, but we will be doing Zen. We have some support for Zen VMs that we need to polish up, right? And I think at that point, particularly across Exogenie and the various Protogenie-based aggregates, I think things will be substantially easier there.
Yeah.
In terms of having that image, but the bare metal ones are probably going to be problematic for the foreseeable future.
But I think we may be able to get past some of that if we really do limit the set of, and I don't want to see images, because I think we're not talking about common images. We're talking about common Linux distributions with a standard baseline of packages that you can expect to be installed. So if we say, look, we're going to have one modern, long-term supported Deb-based and one modern, long-term supported RPM-based Linux image available on both Exogenie and Instagenie racks.
Right.
And when you load that, you expect to find Linux 2.7, not 2.6, or whatever it is. And the answer is the same for each of these. Then you can start figuring out whether you put little percent signs or curly braces in your format strings in your, in your Python-based startup scripts, and you don't have to have 18 versions of those. Then when then you can have reasonably high confidence that if you want to put an Apache server on your machine, you know how to do that.
Yeah, for sure.
I don't think we know how to do that today. That's probably a baby step that helps a lot.
Mm-hmm. It would help a lot. These last two slides are just to seed the conversation a little bit more. As I've mentioned, there are differences. There are differences between the different platforms, between the different environments that we're going to be given. The question is, what constitutes significant differences? What are the issues? I think we need to identify from the experimenter community, the experimenter community needs to help us determine what are the critical features, the critical capabilities, and so on that experiments rely on. First, then we need to say, well, is there some way to do that? We have to make sure that it is possible to do that. And then we want to minimize over time the differences in how those features are experienced, how you use those features, how you install them, how you interact with them, so that they're both available and uniformly available. And I think it's not, I don't want to overstate this problem. I think that there is a fairly straightforward, uniform way to do a lot of things. But there is this gap, and I'd like to minimize it as a goal between the developer community and the experimenter community over time. So why are we talking about this here at the Experimenter Roundtable? The real reason is, yes, there are differences. There are differences between platforms. Those differences are probably going to grow as we add new different kinds of platforms into the federation, as we federate with other kinds of things. But the question is, what is a significant difference? And that's not something the developer community gets to decide. That's something the experimenter community really has to help us set those priorities. What's an annoying difference? Something that oh yeah, I've done that. That's, I just have to, do uname minus S instead of uname minus A on this kind of thing. And what is really a pain? What is really a showstopper? Something that is a serious impediment to your progress. If we can understand what are the differences, what is the priority of those differences, we can deploy some effort to try to limit the impact of these kinds of differences. And so what I'm hoping here, right now in the room for a few more minutes as we can, and then over the next months, let's open up a conversation between the experimenters who set the priorities and the developers who really sort of suggest solutions and estimate costs. We can do this thing, but it's not that easy to do. So let's, we as a program can sort of fit those things. But I'd really like to have that conversation started up between what's important and what's possible. And that's all I had to say on the slides. So let's open it up. Are there any other experiences people have had with these differences, or any other approaches that people would like to brainstorm on?
So go back to the experiment, loading an image to the machines. Is it the same as MLab? Because MLab has a list of images you can load up.
Yep. So the way that this works now, an advertisement does contain for every node a list of the known images that image supports, or that node supports. And I believe that Exogeny does this.
But do you guys want to do the same thing?
Yeah. So and then for the Protogeny based aggregates, there is now an extension to the AIM API. It's not actually part of the AIM API. We define an extension to it that lets you take a node that you already have and say, I want to take a snapshot of this, and then that will appear in your list of images the next time you go to create one, right?
Okay.
So that is there now. Like FLAC supports it now. If you make an experiment in FLAC, you'll notice that once the slice is created, there's a new extra button that lets you take an image.
Yeah.
And then, like as I said, it will actually show up in the advertisement, and if you
thereafter,
FLAC, it gives you a little drop down box. So that has not been there very long, but it is there now. Another feature that Nick alluded to that we just added is if you make one of these images, you are actually given a URL, and that URL can be fed to any other reasonably up-to-date Proto-Genie aggregate manager, which will fetch it in front of you.
And does it work well? Because when I tried with MLab, I made an image and then it just didn't work.
Okay.
And so I don't know how well it is.
Yeah. So at this, so one thing that is not exposed to you very well at this point is like, if your image doesn't boot, right? We don't give you any nice way to see it, unfortunately, right? And that would be valuable. We're not doing it right now. But the idea is, since for us all of the Instagenie racks are going to be separate aggregates, right? And I don't want you to have to make an image on every single one of them, right? And so that's basically why we implemented this URL-based thing, so that you'll make an image, it gives you a URL. Next time you make a slice, you can paste that URL in as the image ID, and it will go fetch. You will go fetch the image in front of it. And right now, we have a completely ad hoc made up format for the metadata for that image, and we have been talking with the Exogenie people about how we could support images that have their metadata on it. So that, but I can't really guess as to how long that would take to get that one.
They seemed interested. I saw Lee and Victor talking.
Yep.
They seemed very interested in that.
That's great. That's great. Other thoughts, comments? Well, give this some more thought. I'm hoping that the experimenters among you and the developers among you can really be thinking about these issues, and let's try to identify critical problems and minimize that gap. Nikki.
Something last, and I don't know if we have any tool developers here, but another important thing would be, if you're developing a tool for experimenters to use, make sure it can support multiple
Yes.
OS again. Because right now, you want to use this tool, your nodes have to be running a specific version of Fedora or Ubuntu or whatever. So it would be nice if the tools can also be run on multiple.
Absolutely. Very important. Yeah, Mark.
I'd like to express a possibly contrarian opinion. I want to do it briefly so Ilker has a chance to say his piece in a minute. I think there's a common assumption that more images is better, and that the only hard part is maintaining them. I'd like to argue the opposite, that more images is bad. And the reason why is, as an experimenter, when I create an image, and I've done a lot of magic to get whatever capabilities I want installed in my image, it becomes opaque to others. The only way that I can guide someone to replicate my experiment is to say, load my image. And if I've made some mistake or done something perverse in that image, it's going to be very difficult for someone else to get the same results I got. Or it's going to be very simple for me to get different results and difficult for them to understand why. So if we can sort of build a platform that makes it reasonably easy for people then to execute a set of steps that gets them to a predictable state. If we can make the startup scripting easier so that you don't have to make images, I think that's better. But I'm not sure. Not sure everybody agrees.
So say more about what it would need to make startup scripting better. I'm not saying startup scripting is like amazing and perfect, but what would that mean?
So I think there are basically two reasons why people want to make custom images. One is because they don't know how to get back to the state they're in right now. And
or aren't confident that they can.
They know what I've got now works. I'm not 100% sure I know how to get back here. And that's what making the startup scripting easier would be something so that you know how you got here, and I feel confident I replicate it. And the other reason is, well, I know exactly how I got here, but doing it again takes 3 hours. And I don't really want to have a 3-hour cycle time to rerun my experiment. So I'm not sure I know how to fix that. But
Well,
anyway,
I mean, taking an image is what the second one is for, right? I mean, that's the situation I, have found myself in, where I know how to get from A to B. Unfortunately, it's, and I have completely scripted it out, and it still takes the machine 4 hours to do it. So obviously I want to take an image. I don't want to use a startup script. But I mean, I can see both of those arguments. But I don't.
Yeah, they're not mutually exclusive.
That's actually great. I mean, publish your paper, you have to publish it with the script, not the image. Whatever. I'd rather publish it with the script so somebody can check it out, right?
Well, that's fine too, but if I want to stand up 100 of them, you know, you want both of those.
Yes, no, agreed. But you don't want only images. Yeah,
We did promise those for.
Nikki.
And if we're doing it for startup scripts, another thing that I found difficult when I'm writing a startup script is whether it will actually work. I don't know if there is an easy way, an easier environment to develop your install scripts and run them faster, because, you know, rebooting the node or releasing your resources, getting them again, and then find out that there was an error on the install script takes a lot of time and it's painful. The cycle is,
it takes a long time, yes.
Install script is right. Is a little bit of a painful process. I don't know if we can do anything to make that better, but that would help a lot in convincing people to actually write them.
Would that be something where you want to prototype it on something like Genie in a box and say, okay, here's the install script, go ahead and run it on a fast localized machine, and realize you can't actually run the experiment. And once you have the script tested out, then you go ahead and deploy it to the real environment.
Yes, although you know that right
That's a neat
now
thought.
the install script is again specific to the OS image or the. So again, the engineer box will have to be able to replicate the behavior of the actual nodes. But yes, that would be something that the engineer box can be helpful for.
Let's call this. I'm sorry, I think this is fruitful, but we have 13 minutes to be in another room. Ilker wanted to make a completely unrelated pitch in the area of performance isolation. So
Great.
Okay. So I'm a Genie experimenter for 2 years, and I'm working on a network security experimentation, specifically doing denial of service. But it's not really possible to do this experiment on the Genie, so we are using the Clemson resources. So I'm not using any Genie tools to request this tools, and I can't use the monitoring and measurement tools again, all these really nice, helpful tools. So I was wondering if it is possible to allocate some resources for network security experimentation. So we can also use the same tools, and after finalizing the setup, maybe getting a time and doing the same thing on the large.
Just to clarify, when you say you can't get resources that are for which there are performance guarantees. I mean, you can't.
The problem is if I do a denial of service, it will definitely affect other experiments.
Yes. Yeah. Sure.
That's why we're not doing it. It's not because we can't get it. It's because it will affect others. Yes. That's why we are using just a Clemson part of it, so at the edge, so it doesn't affect anyone.
So the question I had then is, how important or how desirable would it be for you to use like actual wide area resources? Like it feels to me like maybe actually using resources all in one place is actually best for a denial of service kind of thing, right? I mean, of course, I realize that you're trying to look at scenarios that are, where they're in the real world or wide area, but it's not.
Yes, it's not that important if you are testing just what will happen if I do a denial of service a certain part of the network, but if you are planning to come up with an idea, so how can I mitigate the attack? So you need more resources, and you need to be able to.
Is it just a matter of more, or is it a matter of like actual wide area, actual wide area links? Because of course, basically, an individual site can provide sufficient sufficient network resources to be sufficiently provisioned so that if one user runs a denial of service attack on the infrastructure, no one else will notice, right? But this is much more expensive to do, right, on links that actually cross the network. So for example, right, you know, there are certain kinds of denial of service attacks that I'm very sure people would notice and overlap. But the vast majority of them, right, like, you know, flooding with minimum size packet, you know, minimum size regular packets and stuff, right? I would actually be entirely comfortable with you running those in the emulative provisioning cluster that we have at EPOPs, right? Ones that made the switch CPUs do more work, I would not probably would be a problem. But so there we have enough. I think we have enough performance isolation that you can do them on the shared resources, right? But getting that same, but this is because we have switches that are very over provisioned and so forth, right? Whereas doing that across a really wide area network is, as I would say, basically too expensive, right?
Yeah, I mean, I didn't use the GE tools to request resources, and
Yeah.
I'm not really sure if I can check if there are any other experiments going on the same infrastructure. Can I do that?
Yes, we're working on that. The monitoring tools are we're collecting slice and sliver information, so you can go and look and say, hey, on this VM server, there are other servers running on this machine.
And how am I going to decide which ones I choose that I'm going to affect others?
Right.
Yeah, it should be tagged